Today's topic is summer or the ADA circuit. You know well, input impedance of the op amplifier is extremely large. So therefore, more than one input signal can be attached to the inverting or non-inverting terminal of the op, and then such circuit gives the addition of the voltages applied at the inputs. This is a circuit diagram of inverting and non-inverting terminal. To the inverting terminal, two resistors are attached in parallel and two input voltages are connected, V in 1 and V in 2. R1 and R2, and here there's an output voltage, there's a feedback resistor, let we call it RF. The positive terminal is grounded. Here current flowing is I1 through R1, and through R2 current flowing is I2. Because op never draw any current, so all of the current will pass through RF. Now because point A is grounded, that means potential at A is equals to 0, and due to virtual ground concept, voltage at A equals to voltage at B. Therefore, voltage B will also be equals to 0. So V1, V2 will be equals to 0. Now let the current I1 is written as the potential difference divided by the resistor. Potential difference is V in 1 minus V2, which is 0, divided by R1. You know V2 equals to 0, okay? So I1 becomes V in 1 upon R1. Similarly, you can write I2, which is flowing through R2. It becomes V in 2 divided by R2. And you know I becomes I1 plus I2, and all of the current will pass through RF because op never draw any current, op inputs. So I is the sum of the two. Let me write the I across RF. Across RF voltage is V2 and V out. So V2 minus V out upon RF. V2 equals to 0. Therefore, I becomes equals to minus V out upon RF. Now this is the current I total. This also current I. So the left hand side same, equating the two. Okay, equating the two I and simplifying the expression. Very simple. R1 equals to R2 equals to RF, all the registers are same, of same value, then output voltage becomes the minus of the sum of 2. So this is addition, but the phase will be inverted because of the negative sign. Output voltage it is minus of V in 1 plus V in 2. Addition plus phase reversal. Okay. This is a circuit for non-inverting summing amplifier. This operation amplifier minus and plus terminal. The input voltages are applied to the plus mean non-inverting, V in 1 and V in 2 through resistor R1 and R2. Here the voltage is V1, current flowing is I1. Here I1 and through R2 current flowing is I2. This point is B inverting terminal. It is grounded through R and output is connected to input, the feedback resistor RF. The RF current flowing is I and it is passing through the R. Okay, this is all about the circuit. Now, voltage at the point A is equal to voltage at the point B. This is the characteristics of the op. V1 equals to V2. Op amplifier inputs never draw any current. So here it will not draw any current through this terminal. So I1 plus I2 the sum becomes equals to 0 because op never draw current. Op inputs never draw any current. Because I1 plus I2 equals to 0, I1 is written as the potential difference across R1, that is V in 1 minus V1 divided by R1. Similarly, I2 is written as potential difference across R2, which is V in 2 and V1 divided by R2. That's equals to 0. Now simplifying the expression. The current I across R. The potential difference across R is V2 minus 0. Now I through RF. The potential difference is here V0 minus V2 upon RF. Now because these two currents they are same, let this equation and this equation. Okay, equation 2, equation 3. From 2 and 3, because I are same. So equating the two. And because V2 equals to V1, so replacing V2 with V1 now. Replacing V2 with V1. Okay. Simplifying the expression and getting the value V0 from here. Now substituting the value of V1 in this expression, so therefore now V0 becomes if R1 equals to R2 equals to R lit and equals to RF, then voltage becomes equals to V in 1 plus V in 2. The output voltage is the sum of the two input voltages and output will be in phase with the input.